All right. Hi, everyone. We're gonna give everyone a few minutes to roll in to the call. Usually, in 2 or 3 minutes should do it. But just as a quick preamble, we're really excited to be hosting this live discussion between Datch, Oden, and eTech Group. AI is a hot topic for manufacturing leaders, and many of you guys are excited for what this technology can do for your business. With all technology adoption, we need to start with the problem first. Manufacturers are consistently sharing that workforce are their number one challenge, or is their number one challenge. And this presents a great opportunity for AI to have a big impact for manufacturers. So we're asking this question of, how can leaders ensure that the investment they're making is effective? So we're looking forward to, discussing how, you can boost productivity, overcome challenges, and arm today's frontline workforce with practical data to drive efficiency. We'll jump into intros with the panel in a moment as we kind of let everyone roll in. But just as a quick introduction to myself. I'm the CEO and co-founder at Datch, where we focus primarily on asset management and applications of AI in the asset management space. My background before Datch was in aerospace manufacturing, and in a previous life, I was also working in shipbuilding and submarine engineering back in Australia, where I originally hail from. I've spent my whole career in the manufacturing space with both the focus on production systems as well as maintainability of assets. And I work with some very smart people at the forefront of this, still emerging field of AI. As a yeah, I guess like we're gonna jump into intros with the rest of the team. But just as a quick agenda, so we'll do those intros, and then Peter will talk through the labor challenges from a production perspective and how Odin is tackling these. In a similar way, I'll talk through these challenges from a kind of a maintenance and asset management perspective, and how Datch is uniquely thinking about these as well. And then we're going to open up the panel for what I expect will be a very interesting discussion. So, without further ado, I'm going to pass it over to Peter.
Yeah, thanks, Mark. Hi, everybody. Good to see everybody on the panel here, and thanks everybody for joining. My name is Peter Brand, one of the co-founders and president at Oden Technologies, based in New York City. We've been at it for about 10 years now at Oden. We supply predictive quality and predictive analytics for frontline workers, including operators, in manufacturing focused on production. So, how to make sure that operators can optimize their workload, optimize the process in real time. So really excited to talk about the problems facing operators, as well as some solutions out there in AI. Kyle, would you like to go next?
Nope. Yep. Hi, everyone. Mark, Peter, thank you both for having me today. Kyle Winters from the World Economic Forum. I sit with our Center for Advanced Manufacturing and Supply Chains, one of 10 thematic centers at the forum. We're really looking at if it's made, if it's moved, across 19 plus different industries. So really looking forward to hopefully injecting some of the macro trend work that we've been looking at over the last year and hearing from you all kind of the realities that you're facing on the ground as well.
And Pradeep, we'll kick it to you next.
Yep. So thank you, Mark and Peter. This is Pradeep Paul. I work at the eTech Group. We are one of the largest system integrators in the automation space in North America. We work with the different industry sectors, and we do all these services, whatever you need within your manufacturing sites. We started doing a lot of automation and manufacturing intelligence initiatives with our partners Oden, and would love to share what we have done and the successes we've had. Thank you.
And last but not least, Samuel. Sorry, Samuel, can't hear you right now.
Okay. All right. So manufacturing integration leader, in BASF, just for context, BASF is the largest chemical manufacturer in the world, based out of Ludwigshafen, Germany. And I work for the global engineering department, looking into new technologies to improve the efficiency of our plants. Right now, I'm in charge of the North American footprint, which is encompass around 120 manufacturing sites. And some of the exciting things that we're doing is doing a lot of integration of data, MES, working a lot with AI, and trying to improve our efficiencies with technology that adds value more than just cool technology out there. And we're looking to add value to our operations.
Thanks all. So before I pass it over to Peter, just a quick bit of housekeeping. So this is being recorded and will be sent out after the webinar. And then the other thing is, if you have any questions to the panel, we have a Q&A box in the Zoom window, which you should be able to find fairly easily. So if you have a question for a specific panelist, just indicate that in the question itself, or you can open it to the whole panel. And if you do want to speak up, you'll be muted. So make sure you throw the question in the box. Cool. All right, I'm going to pass it over to Peter.
Thanks, Mark. So again, Peter Brand here at Oden Technologies, and really what we're doing is making sure that useful insights and real-time predictive and prescriptive recommendations make their way to operators, can be used on the front line in real time. But I think important to start with the problem that we're actually talking about, why we're all here speaking about the frontline workforce. I think this sums it up pretty well, right? Since about 2011, labor productivity in the manufacturing sector is actually down. I mean, and that's after massive gains for decades due to a number of factors. But what I think a big takeaway for me from this is not only is productivity going down, but we also can't rely on sort of the same approach to automation that we traditionally took leading up to 2010 or so. There needs to be new solutions to help boost this up. And you can go to the next slide. On top of it, and this isn't, this is certainly correlated, a massive change in the workforce for a typical manufacturer just in the last 4 years. So since 2019, the average tenure of a worker in a factory, and I think that includes hourly workforce as well as engineers and everybody else around them, has gone from 20 years to 3 years. And that's an average time in position of 9 months, down from 7 years. I mean, there's some customers that we talk to that have an average retention rate or an annual retention rate of less than 20%, 30%. So this is a problem that is pervasive everywhere, and it's generational. There isn't one easy solution to reverse these numbers. So we're going to talk about some things that we can do right now to address it. You can go to the next slide. I think a good way to sort of sum up this issue is, how do you turn a new operator into an experienced operator in a matter of weeks instead of years? Some customers that we have, it's not 2 years, it's more in the order of 10 years to get an operator from 30, 40, 50% productivity to that 90, 95th percentile. And in this environment, that's just not sustainable, right? So how do we build institutional knowledge in weeks instead of years, especially where current automation and technology isn't quite cutting it? The barriers in the way right now are, being able to respond to changing conditions independently, proactively making improvements in business-oriented decisions. It's almost impossible where you've got very complex processes with hundreds, if not thousands, of process conditions that are changing all the time. You also have business landscapes and supply chains that are more dynamic. You have faster changing constraints or conditions that you're optimizing for, where one week, you're optimizing for output, the next week, it's more about cutting costs back. So how do you give everybody the tools to, be proactive in that changing environment? Starts with, the data set, turning those sort of billions of data points as they add up every month or a year into, actionable insights through the right acquisition and architecture and models to make them useful. On top of that, you got to be able to automatically filter for the right kind of production that you want to inform those models with. So knowing high variability versus low variability, understanding current constraints on one line versus another, one product versus another. Identifying the best settings to reach your specified goals, knowing that, there might be different trade-offs on every asset for every product. And then, and this is the most important one, how do you get all those insights communicated to the operator in a way that they can understand and action on it in a moment? Where, an operator already has 10 things going on, their number one priority is always going to be keep that machine or that line running. The insight, that powerful insight, has to also be super simple and actionable. So this is a real screen from Oden's Process AI tool and this one's for a paper manufacturer. So first, on the right-hand side, those white panels, you see that, we're predicting quality versus the last actual QC test in order to sort of create the underpinning of the recommendations. So you can look at it as, an indicator that lets, the operator know that any change they're making is going to keep them with good quality. But it's also turning, for many industries, what's a quality test that happens offline every few hours into a quality test that's happening essentially every second. But then on the far left-hand side, you have a way to understand your trade-off between energy or material consumption and costs versus speed, and selecting the right place to be on that curve. And then getting the recommendations, you see it in the middle in the color-coded panels, of what to do to increase speed and all the other process conditions that have to be adjusted in order to achieve that. And then on the bottom, and this is also, important, making sure that operators and everybody around them can see that immediate feedback loop. Like, what are they saving? What are they earning in real time? Are they winning? So what that's resulted in is, one customer here in the chemical space saw a 40% increase in average run rate. And you see here the dark green bar is the average run rate after Process AI. And what's cool to see is not only is Process AI helping them get up to their targets, but in some cases, they're actually exceeding their targets. And you go to the next slide. And I think this is the coolest thing, kind of bring it back around to the operator. A wire and cable customer of ours saw a similar increase in production rate, 20% in this case of using Process AI over 3 months. In that 3 months, that translated to over 5 million additional feet of product over their historical benchmarks. And they overperformed those benchmarks 84 out of 90 days. So it was consistent. It wasn't just, here and there. But when you look at these right-hand panels, what it also tells you, and what we saw, was not only are you closing that gap between new operators and experienced operators, you're accelerating that new operator to having institutional knowledge that they can use, but you're also bringing experienced operators into a whole new realm of efficiency you're allowing them to exceed what they've previously been doing. I'll pass it along to Mark.
Great. Thanks, Peter. Cool. Just give me 1 second. Cool. Okay, great. Yeah, thanks, Peter. So from my side, as a quick overview of what I'll be talking about over the next few minutes, here at Datch, we're really focused on applying AI to asset management challenges, whether that's kind of frontline diagnostics, planning, or reliability use cases. Today, I'm going to be talking about the labor challenges surrounding the frontline aspect of asset maintenance, and then share a little bit about how we think about solving some of these problems with artificial intelligence. Cool. Next. Yeah, cool. Thanks. So when it comes to asset management, we know that everyone is fighting to be, more preventative, proactive, and predictive with their maintenance. Unfortunately, teams are just not where they want to be, and reactive maintenance is still far too high. There was a study conducted by the team at Reliability Solutions where they interviewed teams across dozens of large enterprises, and they found that almost every team was performing well below what they considered core proficiency. So proficiency was really defined as the percentage of intrusive disassembly, reactive to proactive, reactive to proactive maintenance ratios, and then reduction of failures. One of the primary causes of this is what they described as the circle of despair. Remember that phrase, which is something that we've seen across our customer base pretty comprehensively. In a nutshell, the workforce is getting less experience, tacit knowledge is disappearing, and turnover is too high. And this is often what kicks off this cycle. And so what you see is, if you're inexperienced and you haven't done a certain job before, or you don't quite have that tacit knowledge, it leads to installation and assembly errors. And this in turn leads to reduced resistance to failure, and reduction in the kind of mean time between failures, which then, if you want to just kind of click along these, yeah, that'd be great. Which then leads to increased downtime, which then, as everyone knows, leads to emergency fixes that shorten asset life. Technicians become firefighters, and then that leads no time for identifying and correcting the root issue. Then quality of work fails to meet expectation, and you get infant mortality on assets that should be, up for longer, available for longer, and should have longer lifespans. And this also creates its own loop again, because you're only doing reactive work. Everything just becomes firefighters, and often I've seen many facilities, plants, putting their hands up, saying, I don't know how to fix this. We can't get ahead of this. And part of this is just that tacit knowledge isn't there because the increased turnovers continue to occur. So next slide. Cool. So I want to share kind of a new way of kind of a new paradigm that's emerging when it comes to artificial intelligence and how it can help to solve this problem. So the history of software supporting solutions for real world problems has often lived in the structured data space. So structured data is can be defined as things like machine data, sensor data, SCADA data, sometimes environmental data, but essentially the numbers that exist in rows and columns somewhere in a database. You can aggregate that information, and when you can aggregate that information, that leads to the ability to understand trends and see patterns and make predictions off that data. And there's a lot of good work being done in this space, but one of the problems is that most of the tacit knowledge that exists across an organization lives in that unstructured data space. It either lives in people's heads, or if you're lucky, it lives somewhere in your digitized documentation somewhere. And so that's things like it might be your work history, like something that sits in SAP. It might be documents, OEM manuals, drawings, parts lists. Sometimes training videos with LMS systems. But there's kind of this vast, often untapped space of unstructured data where if you want to understand things in the same way that you do with structured data, you need to throw a whole lot of humans in the loop to make sense of often not quite enough data. And so really our goal, if you want to jump to the next slide, is to kind of make that unstructured data as useful and scalable as the structured data. And so a way to think about this is, where you have algorithms in place, if you double your asset base with the same assets, your algorithms scale across with that. But if you're doing work that lives across this unstructured space, often you'll have to, double the workforce to manage that. Never mind, meet the needs. And so really there's a huge opportunity here to make that unstructured data as useful as the structured data. So you want to jump across next slide. Cool. So not to dwell on this too much, but really there's a way to make sense of this, and I'll talk through this in the next slide. But I think the kind of four components of this are through data ingestion, through mapping relationships, then there's data enrichment, and then there's the ability to use combine that with AI and drive operational outcomes. Next slide. Cool. And so you can think of this as a bit of a recipe. If you're investigating this, these are the 4 steps I would recommend. The first piece is what we describe as setting up data ingestion pipelines. So you've got information in different sources, and you want to make sure that you're pulling those sources, understanding kind of roughly what these sources are, but on also being able to ingest ongoing data, not just historic data. The next piece is basically what we describe as the ontology step. So this is the building out of a knowledge graph. A knowledge graph is different than a traditional database, which is, again, rows and columns structured. Knowledge graph is more about mapping relationships between entities across a space. So, how does a work order relate to a work request, and how does that work request relate to system errors or fault codes, and how do these relate to parts and people, et cetera, et cetera. So once you've mapped out the architecture of that, the next step is enrichment. So enrichment is really, the first step of where the magic happens. And this is where tribal knowledge, which would normally just be tribal knowledge, can start being treated as structured data, so that you can create insights off that data. And so there's some really scalable ways to do that now. Then the last piece is just basically using AI in more and more advanced ways to turn that data into insights. So what would normally be scattered, disparate, unstructured information is started to be treated like structured data, so that you can understand trends and patterns and make predictions off that data. All right, next step, next slide. Cool. And just a quick customer story to kind of tie this together. So this one comes from a CPG customer of ours. They were very much caught up in that cycle of despair, and didn't quite know how to get out of it. They had very high turnover. Experience was dropping through the floor. And mistakes were increasing. And so they had 2 problems they wanted to solve. One was increasing mean time to repair, and the other one was pulling engineers out onto the floor to help them resolve maintenance problems. And so they applied this kind of framework to what they were doing. They kind of mapped out their assets and their history and the documents. And as a quick kind of reference case, an asset goes down, maybe it has an alarm code against it, and they say, I've had, what's going on with this asset? And very quickly, because there's a knowledge graph and there's an AI operating across that knowledge graph, it can say, okay, this hasn't happened on this asset before, but it has happened on a similar asset in a similar way over in the plant in Kentucky. And it's happened 3 times in the last 6 months, and this is how it was resolved each time. This engineer is this other technician, John Smith, is the most familiar technician. And page 453 of the OEM manual, there's some work instructions for troubleshooting this very alarm code. And applying this at scale has been really transformational. So they have a category called complex fixes, which is generally these kind of half-a-day jobs where there's disassembly involved and troubleshooting involved. We've seen mean time to repair reduced by 23%. And they often describe this as kind of a reliability engineer in a box, where they don't need to be calling out these folks that are supposed to be working on kind of higher order problems to be solved. So yeah, some exciting stuff. Some of this technology is still very much in the emerging stage, and we're seeing it apply across asset maintenance in a really powerful way. So cool. I think that's all I wanted to share on that. Just kind of food for thought. So we're gonna open up the panel for discussion. And I think I'm gonna ask the first question. And I'm gonna throw it to Kyle, actually. So given your global perspective at the World Economic Forum, what sort of data are we seeing at the macro level to substantiate what everyone is feeling at the micro level when it comes to labor challenges in manufacturing? And with that, I know it's early, but are you seeing any trends in how technology or AI is reshaping frontline labor, particularly in addressing the experience gap within the aging workforce?
Perfect. Yeah. Peter, Mark, thank you both for the insights that you all provided from Oden, from Datch. Definitely kind of more of that micro level of what we're seeing macroly. So maybe to take it back a step, what my team has worked on for the last year is kind of we've been able to sit down and run these surveys with about 350, 400 senior executives, and then back it up with about 60 kind of consultations with chief supply chain officers, chief operating officers, and the likes. Really to look across 5 different kind of trend patterns that are reaffecting value chain configuration. So when we really dive into that note on workforce, right, the kind of top disassociation between operational efficiency kind of rhetoric versus reality that we're seeing is that, right, there's this 60% need for workforce retraining for a skills gap by 2030. Yet where we currently stand, only 23% of these kind of executives believe that their labor force has the skills to even dive into that next rewiring or next kind of upskilling and reskilling journey. What we were able to do, though, with those kind of executive consultations, that kind of survey data, we're able to identify kind of leaders based on market share that have been able to kind of ride out, these disruptions that have emerged like COVID and lesser black swan events like port closures and whatnot. And we've seen kind of a top kind of 5 skills that have emerged as priorities in like their hiring practices. The first kind of being analytical thinking, creative thinking, resilience, flexibility and agility, motivation and self-awareness, then curiosity and lifelong learning really coming as priorities. And then that's being coupled by a few key actions that we're seeing from this kind of share of leading organizations. The first being kind of continuous investment in workforce upskilling and reskilling, right? Not just that one-off program or ad hoc approach when disruption happens. The second really being empowering operators and working groups to make decisions based on real-time kind of scenario-based data, exactly like you were saying, Mark. And then the third is a little bit of an interesting kind of structural organizational shift for flexibility and fluidity. And that's really taking kind of a broader functions approach and looking at how you can kind of have almost up to 80% of your operators working across functions, while you balance about 20% in more specific and specialized capabilities and roles. And what I think is super interesting here is, right, when you start to bring AI into the equation, you're looking at about 64% of these organizations that are acknowledging that AI solutions are going to be their key to driving supply chain improvement and figuring out that kind of gap between where their employees are and where they need to go. Yet only 1% of these organizations that we surveyed have actually been able to eliminate manual tasks like Excel spreadsheets, let alone upskilling or reskilling their employee base. And I think this is really interesting when we start to look at what my team has done since 2018, which is kind of our flagship program called the Global Lighthouse Network. It's a kind of a conglomeration of 172 sites around the world. It's an application-based award, 12 of which are actually in North America. So each applicant submits kind of 5 use cases on how they're looking at expanding technology kind of beyond their 4 walls, across their value chain, across their operations, and across their workforce. When we start looking at like the AI lens of that kind of cohort, right, 42% of these use cases, so we have about 850, are AI driven. And in our most recent cohort, 9 of those are Gen AI. And when you start to look into those use cases from this cohort, kind of 3 big things start to emerge. It's first and foremost AI-enabled order forecasting and supply chain planning, really looking at that intelligent ecosystem component with predictive algorithms. The second is really focusing on supplier quality connectivity. So moving beyond just kind of my own workforce and looking at my suppliers, not just design and R&D, but their workforce. And then the first being the third being algorithmic kind of dynamic scheduling for orders, really looking at predictive platforms to optimize production capacity and scheduling, and bringing that awareness down to the shop floor. So, operators and frontline workers understand where these kind of decisions are coming from. When we kind of zoom out on this, the team takes kind of like a 3 A's approach, we call it, right? So it's this automation, augmentation, and autonomy, right? So we're not looking at one in any which silo, but kind of building a little bit of a package with that kind of, human-centric mindset at the front of it. I think as we get to, Mark, your second question on looking at kind of workforce trends and AI a little bit, and this is to preview a bit of an insight that we'll be publishing in a few weeks. So I won't name any of the case studies that we have, but happy to share kind of that link when it comes live with you both for the broader audience. We're really seeing kind of 6 core talent capabilities emerging that are being adopted by leaders to really outpace peers. And the first kind of comes with workforce design, really setting talent requirements for new employees that are compatible with future tech roadmaps and ensuring that tech is not just being introduced to augment, but also to protect a workforce. The next is kind of talent planning, right? A lot of leading organizations are kind of turning to machine learning to kind of find potential gaps between their talent demand and their supply, allowing for both a more flexible kind of hiring process, scheduling process, as well as that agility that you mentioned to the changing realities, Peter, that I think all organizations are facing across their value chain right now. The next kind of hits at attraction and onboarding, right? So using tech to not just streamline and source your hiring process, but also in the onboarding process itself, particularly with utilizing things like VR and training timelines. Just very briefly, the last 3 here are talent development, talent effectiveness, and then culture and experience. And I really just want to hammer home on the culture and experience because it's something that really stood out in a lot of these operator interviews that we've conducted over the last few years, right? Creating that 2-way communication between your operators on the ground and leadership in office is just seen as such an added benefit to compensation, benefits, and just that overall work environment.
Sam, wondering, would love to hear your experience on that front as well. I mean, since you've been leading some of these initiatives from the front line.
Yeah. So something important here that I would like to highlight is that majority of the AI benefits that we are seeing, the frontline workers, is the digestion of the data, right? That not necessarily will translate to close the gap. However, if used wisely, it is closing the gap between the new generation and the outgoing generation. Okay, that's what we have seen in the front lines, kind of gathering that experience that is living out of the door in the coming years, right? And using AI and the fact that we can work with unstructured data to put together a knowledge base that can help us drive the next couple of decades. So for now, that is something that I see a lot of value, and a lot of plans and companies and are pivoting to.
Yeah, and I think Kyle's point and your point about how you align organizations is a big one. I think we'll come back to that for sure. In the meantime, want to loop in Pradeep here as well, where I mean, Kyle, you kind of highlighted, like, especially when you're talking about the best plants, lighthouse plants, there's sort of, there's not as much argument about whether AI is going to be helpful to the front line. It's more about, maybe a big question that everyone's thinking about is, like, wanting to is one thing. How do you successfully actually implement a solution, especially in complex changing manufacturing environments? Pradeep, you've done this successfully with companies. You've helped them see value. Can you give us like a practical example of successful AI use for like the frontline workforce, and kind of how you got there, how you were able to measure the impact, any learnings anybody can take away?
Sure. Thank you. Can anybody hear me? I think I'm unmuted. Yeah. So before we start with any engagement, we want to first benchmark where our customers lie, right? So we want to look at there are 4 pillars of analytics that we look at. One is descriptive, whether your site is descriptive, whether does it have diagnostic capabilities, whether it is predictive, and the North Star. Everybody wants to be prescriptive. So what is descriptive is if your site currently, if you can trend any of the data, you know exactly when the downtimes occur, when of the OEE, I think somebody mentioned about OEE. What is the OEE of every equipment, alarms, most common alarms? That gives you a lay of the land, what your current site is doing. But you're still reactive in the sense that you know exactly what's going on, but can you be a little bit more proactive? And the next step of the journey is being diagnostic. So one step ahead of descriptive is diagnostic, where if you have a fault or a downturn, a downtime event, can you associate fault codes to that, right? So now that you've got fault codes, you can go in and dig in a little bit more. It's more granular, but again, still reactive. You can have, I think Datch helps out a lot with this, because once you have the fault codes, you can put in all the other asset models, and then you can figure out root causes pretty quickly. But the best case scenario is moving towards the right and moving towards the North Star, which is prescriptive. The second line, what we talk about, second aspect, what we'd like to give is predictive and prescriptive. When you're predictive, you have you've modeled out your systems that you can catch it before there is a downtime, right? So you are more proactive at that point. And to enable all these predictive systems, you need a lot more data. You need connectivity across assets. You need more data sets, and you need data platforms and ML-based learning models to help you with that. Once you've got to the predictive side, then the prescriptive part is like an icing on the cake. Predictive will tell you exactly when your system is going to fail. And now with the prescriptive, you can tell, or if you have to, your yields are going down. Prescriptive is, do you have machines that can tell your operators what to do to increase or to maintain the yields? So with that, I'd like to, I think you had brought out a wonderful use case of a paper AI system that you've built out. And I'd like to walk through that and just go through what are the challenges of this. This is a beautiful slide. So what happens here is, this is an example of an asset, which is a paper asset, pretty complex. As soon as you get a machine like this, there's around 1,000 parameters that you can trend. So not all of them actually impact the quality. So right now in this paper, in this machine, you're looking at 2 levels of quality, of moisture content and tensile strength, right? And these are all offline measurements. When you talk about offline measurements, is when you have something you're producing, you have to go take a sample of it and then test it out. Already doing offline measurements, you're in a lagging indicator of your operations. So the best thing that we did, I think, with the help of Oden, is we modeled this whole process, and we realized there's only 5 parameters that are actually needed. And then you predict the offline targets. So now you got real-time prediction, which is very close to what you have. It was a fantastic model that you guys have done. Once you've done that, you now can recommend steps right on the fly. So then once you've got your model predicted, then you took the next step of adding optimization to it. And here, I think it is minimizing costs, whether it is gas, which affects your steam, how much of gas you're using or electricity you're using, and then the other one is the material flow. So This is almost like putting an Iron Man suit on an operator, right? You're telling him, and this will bridge the gap between experienced and the novices who are coming in, or the new operators coming in. You're giving them, fundamentally telling them exactly what to do. And the best part was, if you look at the bottom line, the cost savings, predict savings based on these recommendations. We're not there yet in closed loop systems. This is, again, it gives you the recommendations based on some between the dead bands between the current and your settings. It actually, the operator still has to put in these set points in manually. But if you do that, you're looking at predicted savings around $2,000 an hour on just one asset. So if you scale it out, 10 assets, that's 20,000, which is a fantastic use case of AI and machine learning for assets like this, and to actually help out with your operators as well as reduce costs.
Awesome. Thanks, Pradeep. I'm going to, just for the sake of time, jump on straight onto the next question. For this question, I think the best place to start with would be Samuel. So Samuel, you've got quite an interesting range of experience in manufacturing. So you started as a process engineer at Goodyear in Venezuela, and now you've worked your way up to North American manufacturing integration leader at BASF. So definitely curious to hear, when it comes to AI initiatives, how do you balance the vision and goals that executives maintain for the business with, the reality of what the frontline workforce has to accomplish and manage on a daily basis? So yeah, what kind of strategies have you seen work best for gaining buy-in from the shop floor, but also all the way up to the C-suite, and then also from operations to IT? Are there any particular examples that you can share as well?
Yeah. So what I do is we do an assessment, and we understand that each side has a different culture and a different digital footprint. And what we do is we try to understand this side and the people on that side, to take them to the different levels of digital transformation that they might have, right? So there is a general knowledge in the C-level suite that AI might do good for us, but yet it's yet to be seen, right? I mean, this is new. Company like yours and others are still trying, I won't say still trying to figure it out, but they're new in the space. It's still new technology, right? And all that information is being cascaded down, and some of these individuals still don't understand very well the effect they can have in the frontline worker. That's our job. My role is to grab all these technologies and try to make sense of what can fit to a particular site, operating division, or business unit, right? What I've seen, like I said, like I mentioned before, a lot of consumption for data, unstructured data. When the Power BIs came in and the tableaus, everybody was excited because we could see structured data, and everybody wanted to have a dashboard. That was the ultimate revolution, and root cause analysis out of the beautiful dashboard ever. Now we got fed of dashboarding, right? And now we're in the next frontier of let's use unstructured data with structured data to make sense. But now we have a lot of data, right? So the question is, how do we add value out of that particular data set? Okay, and that's where the AI comes in, because it's difficult to grab it all and make sense of it. So if you have a failure on a particular equipment, you wanted to point out the top three, top five potential causes to get this done, right, back and running. So we see that a lot of this might reduce the amount of time to get everyone together in a room and do a root cause analysis, and reduce the emails and all that, and get the equipment back and running. And most importantly, prevent that to happen again, right? That's where the value people see is. Now, how to translate that to the front line, how to use it, is the challenge. We still have people running out of Excel sheets, using paper, right? And that's normal. because each plant has their own identity. I call it digital identity, right? Our role is to discover what that is and take it and tag them along to and close that gap between what they have now and what they could have, right? And be careful with not just going to a site that is very basic in offering with a lot of AI tools, right? Because that's the misconnect, and when you lose the buy-in from the workers, because they're going to tell you like, oh, you want to bring me a chatbot here when I don't even have a PLC working. So that's the challenge that we have.
That's super interesting. Yeah, we've seen similar situations on our side. I'm curious to get Peter's input on this from the vendor perspective. You've been in the trenches, selling and providing and deploying AI solutions to the enterprise for 10 years now. So yeah, curious to see how you guys think about this as well.
Well, and I mean, everything Sam and Kyle before that has mentioned here, is so important, because I mean, when you're talking about the front line and digital for the front line, you're including so many stakeholders that have to be pulling in the same direction. I mean, and so somebody like Sam is incredible, and I think this is sort of a newer development in organizational structure, is somebody who's going to bring together operations, the people who are going to be using a system, who are also going to want to see the payoff and probably going to be paying for the system, with IT, with engineering, with everybody else who has to take a role. And at the end of the day, it's all about alignment, education and incentives. And to the culture piece, it's amazing where, you easy to sort of assume it's just about, hey, let's educate everybody, let's make sure they can use the system, but it's also about making sure that they're supported by, the organizational structure around them. If an operator's been told for years and years, hey, just hit the center line, it's about consistency, do whatever you can to not go down, don't worry about optimizing, and all of a sudden, they're giving a technology, said, okay, now hit the USL, now run it faster. They have to know that management, leadership, everybody else is not just going to give them the tool to do that, but support them in that decision making, and that sort of trade-off between maybe something that's a little riskier or something that's perceived to be riskier. So having somebody like Sam to kind of pull that all together in a line, it doesn't happen without it. So I appreciate you highlighting that. I think sort of one question that's probably evergreen in everyone's mind on that alignment piece. I think every environment, when you're talking about digital, is going to include a number of solutions. Some are sort of built or cobbled together in-house. Some are pulled directly off the shelf. Some are a mixture of the two. Sam mentioned, the dashboards and the spreadsheets and Tableau. I mean, Pradeep, wondering what you think here, but, how do you find folks are thinking about the right mix of buying versus building, and what's a takeaway that the audience might want to think about going forward?
I think Sam was also in a good position to answer this, but for us, we look at the skill sets of the employees within the manufacturing site. So most of us look at when you go into manufacturing sites, it's electrical engineers, mechanical, chemical engineers. Very few people with IT or data science background. So when we come into a mix like that, it's easier to go with a vendor like Oden, who's experienced, who's got all the efficiencies built in, and help and drive the time to value for those kind of opportunities and those kind of solutions. So we've also worked with the bigger folks like BSF maybe have their own internal team. But it mostly depends on just skill sets and the total cost of ownership. You have to make sure that once you put the system in place, it's maintainable, it's scalable. When you have certain things that you're going to add on, you have somebody who knows the system well and has the bandwidth to do that. So I know with working with you guys with Dash and Odin, you always have the best customer support, and we take all that for granted. So that's where we assess where we go with, whether it's to build it ourselves or vendor provided. Whenever our skill sets are not aligning with the timeline of the project, we go with the vendor.
Yeah, to me, I can agree with Pradeep. We do have a large team of data scientists and automation engineers, and even now we have AI specialists looking into building solutions in-house. In fact, myself, I'm in charge of 3 AI projects with people around the world. And the challenge is that, right? We can create a good concept, a good MVP, and put it out there. But then the question is, who will maintain this? And be honest, we do chemistry, and we work in operations. Technology companies are in the technology space for a reason, and technology moves fast. So with the infrastructure that we have, um, we're not going to be able to move as fast as people out there, right? And that's a challenge, right? So it is important for us to recognize what tools make sense to build in-house and what tool makes sense to buy it based on the impact that they might have in the coming years.
Awesome. Thanks, Samuel. Thanks, Pradeep. Cool. All right. So we are nearing the end. So I wanna ask one almost a quick fire for the round table here. Curious to, for everyone to look into their crystal balls. Where do we see AI evolving over the next 5 to 10 years? Especially when it comes to addressing this frontline labor challenges. Are there any kind of emerging technologies or trends that you believe will make the biggest impact? I'm actually gonna jump in and answer my question first. Then I'll hand it over to Peter, and then we can maybe just quickly run around the room. So my, there's one takeaway. If anyone fancies going down the Google rabbit hole, there's this concept emerging of it's called agentic AI, or AI agents, so to speak. So this is basically the concept of AI taking up more responsibility across the value chain. So a very quick way, I could talk about this for an hour, but a very quick way to think about this is that agents can support tasks, they can support jobs to be done, and they can go, they can do deep analysis. They have a level of autonomy on how they get to the output, and there's often a social element of what they do, so they can ask questions and clarifications. And it's all about, here's your list of instructions. That's the output we want. Now you go and figure it out on your own. And so at the moment, it's very simple what they're capable of, but that will increase in complexity over the next few years. So a quick example of this is a challenge that we see fairly universally is around maintenance planning. So planners are often drowning in PM work. They'll have, for example, each planner will have 12 PMs on their list for the day. They'll get 8 planned and scheduled, and then 4 will go on the backlog. And then, 6 months later, you got hundreds and hundreds and hundreds of PMs sitting on the backlog that will never get scheduled. Agents will be able to come in and support some of the time-consuming tasks that really give back that capacity. And then we'll start to not just see capacity for completing 10 or 12 or 20 PMs per day, but also improvements in the quality of these PMs as well that will ultimately help with the quality of the equipment, the availability, and supporting the frontline teams, even those that don't have that experience and tacit knowledge. So very interesting rabbit hole. Very very much recommend going down it if you fancy it. But I'm going to hand it over to Peter to get his input.
Yeah, and I mean, I think that's an example of, what you see in any other industry, which is, it's maybe not so much one technology, but it's combining many technologies or emergent technologies and acting like a flywheel that creates the major shift. I mean, you think about self-driving cars, it's not one invention. It's battery technology paired with, computer vision, compared with GPS, compared with just pure compute, et cetera, et cetera. In the manufacturing space, like AR or VR isn't going to be as valuable without AI software to sort of condense that info and make it timely to process. AI isn't valuable without the right data ops, the right data pipeline behind it, network cleaning, compute, contextualizing, security, et cetera. So, I'm really excited to see how all those things come together to where AI, we won't really refer to it as AI in manufacturing probably 10 years from now. It's just manufacturing. It's just the backbone of how people conduct their day-to-day.
Awesome.
Kyle, I'd love to hear from you too.
Perfect. Yeah, maybe just to jump in and to keep it brief. Mark, completely agree with what you're saying about AI agents, something that we're definitely seeing from the supply chain resilient world, especially on being able to like pick up on major disruptions and just being able to shift logistics patterns, resource kind of planning and purchasing. I think from my own personal lens, seeing what you all are doing for the kind of human-centric workforce is just really inspiring. And I think it's going to be even more of a trend as we move forward, right? As we're seeing kind of nearshoring and reshoring take place within the North America context, right? Really seeing an even rise in that kind of lifespan of employees just shifting from one kind of firm to the next, and being able to onboard them in a quick process is going to be crucial. I think one thing that I'm going to be a little bullish on is quantum, and kind of the pace that quantum comes into the manufacturing space versus industries like finance. Perfect. Maybe over to Sam.
Yeah, when it comes to trend and technologies, I do see some workers or some functions being replaced by AI. No questions about that, especially repetitive tasks, data ingestion, data analytics, and some of that. But another technology coming up is what we call autonomous operation. How do we combine all these technologies to actually have autonomy in our operations, right? So it's when this is similar when the actual automation started it, right? You eliminate some functions but create others, right? So it balances the whole equation. So right now we see projects that will rely on different technologies to make it happen, right? So you have AI, a lot of data ingestion, integration, and all these data, and along with robotics and basic automation, all that combined, right, to make complex projects. That's what we're seeing, where we're going, not just isolated automation or isolated AI, the integration of all of it for further developments.
Pradeep, you want to close this out?
Yeah, I think for us, in the short term, it's incremental changes, like even sensors going to MQTT rather than 420, and getting more data out, more augmenting the operator. For us, it's mostly augmenting the operator than replacing them. I'm sure down the line, a lot of them will be automated. A lot of operations will be automated, but it's increasing the productivity of what you have right now, right? So that's the end goal for us, to make sure that the manufacturing is smooth, operators are happy, there's not much of attrition, and wherever possible, automate it and help the operators handle more responsibility.
Awesome. Cool. This has been a fantastic webinar. I just want to comment that this was the most perfectly on time webinar that I've ever seen. Right on almost the second. So to close this out, if you do want to discuss more at whether it's regarding AI and kind of process side, or with AI and the kind of asset management side, feel free to reach out. I think we've also got Pradeep's website on the chat there as well, if you want to talk to eTech. But yeah, thank you everyone for joining. Please touch base. Happy to discuss anything further. And thank you to all the panelists. I know this has been there's been a lot of organization behind this. Also, thank you to those sitting in the background, particularly Krista and Garrett, who made this all happen. So thanks again, and yeah, thank you to everyone.
Thank you.
Awesome. Thanks,
Thanks,
everyone.
everybody. Thank
Bye.
you.
Ciao.